Ignition. Liftoff. Liftoff.
Hello and welcome to AWS Made Easy episode 105. We are doing a special AI Friday. There's some really neat AWS news, some AI news, and we're going to do an awesome demo of Bedrock Agents. I'm Stephen Barr.
Hi everyone, I'm Rahul Subramaniam. And Stephen, so tell us a little bit about what we are going to do today.
Well, we are going to, if you remember a flashback to George Costanza and his pretending on how to be an architect, and we used AI agents. So in this case, we had Lambda functions that were talking to ClickUp to manage George's task list of all the things that he was going to do to pretend to be an architect. Well, we wanted to do the same thing, but with Bedrock agents and Haiku.
So just a reminder, we were doing OpenAI earlier, and now we're switching this over to Bedrock to see how we can get this implemented quickly.
Well, because George is very concerned about his enterprise data needs. He wants to make sure he has a scalable solution, that his plan is private and secure and well managed. So I think he has plenty of reasons. Absolutely.
Awesome.
But first, there's been an announcement that just happened a few hours ago that I wanted to cover. I might have to fold this into next Friday's demo, but this is interesting. I'll put this on screen here. Amazon Bedrock announces new Converse API.
Yeah.
Now, this just happened earlier today. Bedrock announces new Converse API, which provides developers a consistent way to invoke Bedrock models, removing the complexity to adjust for model-specific differences. So this is for the Claude 3 family, Mistral, Cohere, and you can call tools. So what we'll be doing, calling tools. They've got this blog post here. Have you had a chance to read into this too much?
I haven't deep dive into it, but from the documents that I was reading a little while ago, this is extremely welcome. So now, currently, this is what happens when you try to use Claude versus trying to use Titan or trying to use a different service. The main call you make is to the same API, but under the hood, the JSON and everything else, the structures are very different depending on which model you're actually trying to use. So now what they've done is they've basically created a layer of abstraction, which makes it really simple to make one kind of call, and the model is just a parameter, and everything else, is pretty much identical. So I love that fact, because now it becomes possible to keep experimenting and swapping out models depending on which one is the latest and which one does best for your use case. So I love that the number of code changes that will be required to swap out a model is going to be literally zero.
It's going to be pretty cool. I'm looking at Darko's code for Bedrust, which is his Rust-powered Bedrock interface, and you can see here, there's model options to Bedrock call, and this is the sum type. We had hacked on this a while ago. Sum type of all the different models, and say, convert question to model options, and we say, this is Llama 2, so you need to do it this way. This is Cohere. We need to do it this way. This is the other Cohere. We can do it this way. This is Jurassic. So here's all these different ways to do it. And so
you should also take a look at this. So in each one of these cases, you will find that there is a different way to specify the two big inference parameters, which is your top P and your temperature. You'll find that those are all relatively different.
So for Claude, it's temperature and P.
And
But then over here, let's see.
There's another one with
temperature and P.
There's max top P.
Top
P for Jurassic.
So it depends on if it's top P or P. Temperature, I'm sure there's going to be one that's temp or something like that. So this is this mapping that Darko is maintaining. So I think he can probably simplify his code, and for future code that's coming out, for ones that support it, the Converse API. There is a pretty cool user guide that came out with this on the community developers guide to Bedrock's new Converse API. So I really like that this announcement is paired with a nice community.aws post with real documentation.
Yeah.
Do you want to give this one a rating?
Yeah, I'd give this a 4.5 clouds. and definitely simplifies, right? I mean,
Yeah.
lesser code is always a good thing.
And that's the whole point of this one, is to
Correct.
simplify, so you don't have to have that giant switch statement. We're only going to see more models and
Correct.
more models, and so hopefully more of them get folded into this Converse API as it comes out. And this brings me to
Great.
my other point, which I think is really important. When you're using these tools, make sure if you're using Python that you have the absolute latest version of Boto.
Yes.
So like looking at the Boto commit logs, look at this. This was 13 hours ago. Looking at the change log, they just got support for Converse and Converse Stream. So if in your requirements.txt, don't just do Boto 3, you're going to get an older version. Make sure you version pin it to, as of right now, 1.34.116. I'm sure this will be a new one, and by Monday, they might have a new one. So yeah, make sure that you're using the latest version of Boto. And it's kind of cool. This is a neat, if you want to track the changes that AWS is doing in a very real way, this is actually a pretty centralized place to do it. You can see, okay, smoke tests for ACM, Bedrock Agent got an update, Bedrock Runtime, CloudTrail. So it's like, oh, these are all the things that just happened. Because Boto really has to track all the changes to AWS. So long-winded way of saying update your requirements.txt. I'll put it up on the screen, Boto 3 equals 1.34.116.
Yeah.
Don't just pull in the latest Boto 3 or you'll wonder why something doesn't work.
Correct.
All right. Should
What's
we
next?
jump into the demo? Okay.
Yeah, let's do that.
So wanted to show how do we use Bedrock agents. So there's a lot of moving parts. This ecosystem is still new. As you can see, we're looking at code that's brand new, just got committed within the last literally half a day. There's a lot of moving parts to get Bedrock agents to work. So what we want to do is we want to have a Bedrock agent that can call a Lambda function. And then within the Lambda function, there are several choices. So in the Bedrock agent parlance, you have a action group, and the action group. So that's the first thing. When you hear action group, you think, okay, it's a collection of things.
Got it.
But
Can we
the
actually just
action-
take a step back, Steven?
Yeah.
Why don't we just walk through the use case that we're trying to
Okay.
to create, and the problem that we're trying to solve, so that it becomes clear to the audience over here as to what we're trying to achieve with this, and then break it down to the different pieces that we're trying to construct.
Well, let's do a flashback to George from the last AI with George Costanza. Okay. Okay, so we saw how we had George was using ChatGPT. He was listing his tasks, and then that was using under the hood. That was calling a Lambda function, which was interacting with the ClickUp API. So that way he can intelligently manage his to-do lists. He could look at priorities, map them to OKRs, and all of that. Now, when we did that, we showed for each Lambda function, we had to, it was two different systems, right? We had to create the Lambda function, create an open API specification based on the inputs and the outputs of the Lambda function, copy and paste that open API specification into the GPT editor on chat.openai.com. And it was just a bit cumbersome to set up. Now, you could use the assistance API is the way to do this totally programmatically. You can't create a custom GPT through an API with OpenAI yet.
Yep.
So you have to use the assistance AI. we thought, let's do the whole thing in Bedrock. Let's do it with Lambda functions, and as a goal to have it all managed in one code base. So a lot of the tutorials you see, you end up making a Lambda function, and then you have to go through the console, copy and paste Lambda identifiers. I wanted to have it all in one code base where you have your agent, you have your Lambdas, you have the open API schema all in one place and all completely consistent. So that was the
Great.
goal for this. And I think we achieved it using a lot of other people's really hard work. So I wanted to go through all of that. And special thanks to Darko. Darko helped me get my head around CDK. So Darko Mazarosh, make sure we'll follow him. We'll put his links to his live stream and his social in the video description. Yeah, huge thanks to Darko for helping me figure this out. So the first thing is
Awesome.
CDK. So let's do a quick summary. Well, actually, Ro, what do you think of CDK? How would you compare it to CloudFormation, SAM, CDK? How do you see that continuum?
So CloudFormation is kind of the foundation. Okay, most stuff is actually CloudFormation under the hood. SAM and CDK I actually see as wrappers on top of CloudFormation. At the end of the day, whether it's CDK or SAM might be slightly different. But they basically end up deploying CloudFormation scripts. But CloudFormation scripts can be insanely verbose, depending on how complicated an operation you're trying to run. When it comes to CDK, the advantage that you have is that you can actually write your infrastructure as code descriptions as in whatever language you're comfortable with. It could be Python, it could be Java, it could be TypeScript, it could be whatever you prefer. While with SAM, there's a much more concise description of standard operations that you can use or leverage to go create those. So for example, in SAM, you want to create a DynamoDB data store, you want to create a Lambda, and you want to create a bunch of resolvers. There's a pattern. You can leverage the pattern and go deploy the entire piece of infrastructure without getting through every little nitty-gritty detail of IAM policies and your deployment that you would have to do otherwise in CloudFormation. So I think there are levels of higher order of abstractions for all of the infrastructure as code.
So another way of saying it, CDK is like a regular programming language which compiles to CloudFormation.
Yeah.
In that you can generate a lot of CloudFormation using CDK. If you were to use CloudFormation and you wanted to make 10 different S3 buckets, it's 10 different blocks.
Correct.
Whereas here you could do it with the for loop, just like you would in any other programming language. So that's CDK. Now the next thing that I want to go over, so with CDK, to be honest, I'm always a little bit afraid of TypeScript. I'm not a Java person, and so I always get a bit nervous about it, but I use the CDK for Python. But on top of, if you're working with Lambda functions, there's a really cool project called Powertools. So Powertools is developed by AWS, and this is taking Lambda functions and also CDK and adding some really cool convenience. So I'll show this how this works. So with Powertools, you can say define a Lambda function like this. Here's a Lambda handler, and then this handler can have an endpoint called /to-do. And rather than making one handler for each function, you can have a handler that does routing. And through this special app.resolve, and this special decorator, and this ALB resolver. So what this is saying is if you want an API load balancer.
It's basically an API endpoint.
Yes.
And the API endpoint basically has an OpenAI schema that kind of drives it. And all that is basically a bunch of routers. So you define a /to-do as a route, and that gets delegated to an endpoint.
And so there's one for Lambda function URLs. I love Lambda function URLs. So you don't have to worry about cores. You can just, it'll do all that stuff. So you can say Lambda function URL resolver is your app. You decorate this. And then when you deploy this CDK, what will happen is you will get a function URL that will be the output. And then, you want function URL /to-dos. And you'll have this endpoint. This will route right to your Lambda function. You have these other decorators for logging and tracing. So that's Lambda Powertools. Now, the reason I use this is because they have power tools for agents. So power tools for agents, how this works, you can actually you can make a Bedrock agent.
Yeah.
You can make an action group. So in Bedrock parlance, you have an agent, which is the thing that you're talking to. It is you're talking to the model, and the model has an agent which can then choose from. The agent is the instantiation of the model that is configured to do work.
Got it.
And some of the work that you can do is call actions. And so actions are based into action groups. So the idea is we can have an action group for managing our to-do list.
Got it.
And so that will be one Lambda function that can have multiple routes. You can have create to do, update to do, and say close your to do item. And that
Got
would
it.
be one action group mapping to one Lambda function. But and you could have multiple action groups. So say you had an agent where it could check the weather and update the to-do list. That would be two different action groups with two different Lambda functions, and each Lambda function can have multiple supported actions.
Got it.
So with Lambda Powertools, you can create agents. They have a special Bedrock Agent resolver, so you can annotate
Endpoints.
annotate endpoints, and this becomes an agent. And so one of the cool things is that it handles the
Is that
schema
an agent or
generation.
is that an agent tool? A tool that's available to the agent.
This is a tool that's available to the agent. So the whole terminology gets a bit pedantic. But speaking of that, they also have another thing called Pydantic. So
Yeah.
Pydantic is super cool because that helps you generate your open API schemas. So
Yeah.
if you remember in the previous episode of ChatGPT, what I was doing was I was calling my endpoints, copy and pasting the JSON into ChatGPT and saying, generate me an open API spec.
Yeah.
But the problem is whenever I changed the input or the output type, I had to regenerate that,
Correct.
copy and paste. It was a bit cumbersome. I want to do this all automatically. And so the cool thing here is that if you decorate your functions properly, you can call get open API JSON schema, and that will
Nice.
generate you an open API specification. So we're going to see how this all comes together in a moment.
Some tools just find AWS cost savings and make you do all the work. Visualizing cost opportunities is great, but that's not enough. CloudFix, on the other hand, actually delivers those savings for you. And you don't need to worry because CloudFix fixers are AWS recommended and easy to use. It's the only tool that fixes cost savings opportunities and doesn't just find them. It's the easiest way to save money on AWS. It's all 100% automatic and risk-free. And the best part is that it works non-stop. See for yourself. Click on the button to get a free demonstration of CloudFix and stop overspending on AWS today.
Okay, so I know that was a lot of concepts. So just to overview, we've got CDK, which is what's managing our entire stack. So that's going to be the Lambda functions, the agent, the grouping of Lambdas into action groups, tying the whole thing together.
Correct.
We've got Lambda Powertools, which are doing the special annotations so that we get the open API spec. Now, I spent a bit of time, well, mostly bugging Darko, but also a lot of time creating and destroying CDK or destroying CloudFormation templates, trying to figure all this out. And so what we've put together to make this easier is I've put together this template. It's on GitHub. You can go there right now. And this is a public template repository of showing how this all fits together. So
Can you
just
do a
to give
quick go to walkthrough of what it
Yeah.
does?
Absolutely. So how this works. So in the CDK, your main entry point is this app.py.
Right.
And in this case, it is it's saying your main app is this. Let me close this symbols here. Your main app is represented by this stack. So your stack are the collection of all the things
Correct.
in your CloudFormation stack.
And that's your CDK Lambda Bedrock stack.
Yes. And so how this fits together, what we want to deploy, our stack is going to consist of a foundation model.
Right.
Our foundation model is going to be tied to, or so we're going to have an agent that's tied to a particular foundation model. So we're going to say we want a Claude,
Claude
we use Haiku. Yeah, Claude 3 Haiku agent. The agent is going to have two action groups. So at this point, I said there's to-do list and time.
Yep.
Each action group is going to have a Lambda function. And these Lambda functions share this layer called AWS Powertools. So that way, all of that stuff works when you deploy it. So let's look at the stack. So if you go to CDK Bedrock Stack over here, let's zoom out. Here we go. So you create an agent.
Yeah.
And you point it at, okay, in this one it says Claude Instant V1, but change that to Haiku.
Yeah.
You create an agent. Then you create this layer. And this layer, this is managed by AWS. There's a link in the documentation. There's one layer per each region, which gives you the power tools. Then what you do is you make an action group function. So this is your Lambda function. And we're calling this action group function because we're going to add this to the action group. So this is saying, okay, here's a Lambda. It's running Python 3.12. And there's going to be a folder from the root of this project called Lambda. In that folder, there's going to be another app.py. So that's one of the tricky things with CDK projects is by convention, you have a couple of app.pys floating around. You need to know which one you're talking about. So it's saying this Lambda, there's a folder called Lambda. In the folder called Lambda, there's a file called app.py. In that file, there's a function called Lambda handler. And
I assume you could change the app.py and the Lambda. So I know that you can change the Lambda handler, but you can also change from app.py to something else, correct?
Yeah, it's just kind of a convention.
Convention, I understand.
There's multiple app.pys. Then this action group function gets wrapped into an agent action group. And so the important thing here is this name and this description are actually important to be precise about, because Claude or whatever model you're using is actually going to read these when it's doing its dispatch. And it's going to saying, oh, is this where I need to go? So you want to be precise about them. Now, if you had a second action group, you can make a second function, you can make a second action group, and then you say agent add action group. So this is what's giving the agent knowledge about the action groups.
Got it.
So notice also here, when these action groups are being instantiated, they want an open API schema.
Yeah.
And so what this is saying is the input that each action in the action group expects, what it looks like, and what the output's going to be. And that way the agent who's doing the orchestrating between all the different actions and its own thinking can know what to deal with. And Bedrock agents, I've seen that they're a bit more precise about this. So if you say that something is a date time field and you don't return an ISO 8601 date, it's not going to do anything. GPT-4o is just going to do the best it can. This will not do it. So you want to make sure that these are accurate.
I have one question, Stephen.
Yeah.
So typically when you have an open API schema, you have multiple different endpoints. So you can have a /todo, you can have a close task, you can have a / something else, and they would all be part of the same schema JSON.
Yeah.
Are you declaring separate? Are you putting only one endpoint per schema right now? Or are you combining them all under one open API?
All under
schema?
one.
Great.
So I'll show you here. There's a quick preview. So for this Lambda function here, we're doing the ClickUp tasks. And if I open up OpenAPI.json, you can see, okay, here's the paths. I have
/list ClickUp tasks, and then you've got a ClickUp task to complete.
Yeah, so I have list is one of them, and the next one is set to complete.
Yeah.
And then add comment to task.
Yeah.
And so you see this is pretty verbose, and it's saying, okay, this request body is the task add comment request body.
Yep.
And there's going to be a reference to that. Let's see, task add comment. If you see task add comment, it's going to say, oh, that's an object which takes a string called task ID and a comment, which is also a string. So that's where this all has to kind of line up. And that's what the awesome power tools for Lambda is giving you. Is if we go back over to here to power tools, over here, all you have to do is make a Python type of what's going in and what's going out.
Yeah.
And then because this is decorated properly, it's going to generate the input and output type for you. It's like over here, this is just an int, but then it's going to generate an OpenAI schema saying it takes an int.
Got it.
So let's have a look actually using this and showing how this all works. Great. So in this stack here, we've got, let's see, is that we are using Haiku.
Great.
And I'm giving it a prompt. Now, what I'm saying in terms of personal assistance, you were to help with tasks. Here's some things you could do. Then everything else is basically the same.
Yeah. And you got your code.
I've got an action group, which is this Lambda. Now, what I've also done in this one is I've also made a parallel Lambda function API. So that way I can test my APIs without having to get the Bedrock agents to test them. So I've made that in parallel. So that's what this is I've made a separate set of Lambda functions. I am attaching this to the action group. I'm making an action group called time functions. I could update that to say ClickUp functions, but they're functions for managing ClickUp lists. And then importantly, on output, I output the agent ID and also the function URL of that parallel API.
Got it.
So let's have a look at what this all looks like. So now we can go to Amazon. Well, let's do a CDK deploy. I think that's neat to see.
Yeah.
Okay, so we can clear this here. If we do, I'll show you my deployment script. This is what I think is pretty cool. So what it does is it generates each OpenAPI.json for the respective function group.
Got it.
And then it runs CDK deploy. So if I run deploy.sh, now I don't think there's any, I am not in the, let me source.
Virtual
bin. Yeah. Now I should be able to run deploy.sh. It's going to run this script and then this script, and then it's going to see if there's anything new to deploy. In this case, don't think I've changed anything. Didn't change anything. Okay, so this is the important thing. I've got an agent ID, and I've also got this function URL that I can test. So let's do a quick test of this function URL, just so we can have a look. HTTP get, and now we have an endpoint called list ClickUp tasks.
Yep.
And we should see all of George's plans for how to become an architect. Let's see what happens. Here it is. Spend the afternoon memorizing architectural terms, draw some sketches, choose an outfit that makes you look credible. That's all stuff we remember.
I'm an architect.
So now let's get that agent ID. Here we go. that 9 CPO. Okay, so now if we go over to the Amazon console, we see here is the agent.
Got it.
Now, what's interesting about the agent, so we can test this right now. In order to make this work, you need a thing called an alias. And I'm still trying to figure out exactly how this works. But I think what an alias is, it's basically a permanent identifier that you can shift in the back end to various versions of the agent. So, for example, if I can click on this alias here and I can edit it, and I can say, I've made 5-2. And I can say, create a new version and associate it to this alias. And so that way, the alias ID doesn't change. But if I'm updating the version of the agent changes. So it's still all new. And I think this is a little bit of a cumbersome flow. But here's the cool part. So let's say, list my ClickUp tasks. So this is where the rubber meets the road. And what's the really cool thing about here, and I think it's a big, important difference to emphasize, with GPT-4o, it was generating a request, but then it was actually the front end of the web page that was making that request.
Or your client, whatever the client to
Yes.
the OpenAI SDK, or in the case of Anthropic, the Anthropic SDK, whatever code that you write using that SDK is what has to execute the function calls and then return the value back to the LLM.
Whereas here, the actual agent is what's making the call. So if we look at the trace, it's incredibly detailed. So let's look at trace step 1. It sees the prompt and it says, okay, here's where it starts digging into what it should actually do with itself.
And it has the rationale.
Trace step 1. Let's make this font a little bit bigger. Let's move this off to the side. Here we go. Rationale. To list the user's ClickUp tasks, I will call the get time functions, get week to date tasks, include past due list ClickUp task function. And so this, in order to do this, it's reading the open API spec that was generated. And so you want to make sure that that's all set up right. And luckily with the Power Tools, that's what sets it up for you. So now it's coming up with a plan. It's saying, I'm going to call get. I'm calling a Lambda. This is my path. It knows the action group. And now it called it, and here's what it got. So we can see it gets this big JSON object. And now it has to figure out, well, what does it do with all this? And so that's where it hands it over to step 2. Let's close step 1. So this is the end of what it's called, like its orchestration step.
Got it.
So now if we go to post-processing, is there anything? Trace step 2.
Yeah.
You can, if you dig into all of this, it's also evaluating like the risk of taking this, of this call. Let's see if that's actually in step 1. Let's see. There should be something about
One second.
no problem.
There we go.
This is, you always follow the guidelines. So this is all system prompts.
Got it. This is what these are the guardrails that basically help the LLM answer the question correctly.
Yeah.
Or within the bounds of what is permissible.
Yes. And it's saying this is an okay action to go and take.
Yeah.
Okay. So now we go back to trace step 2. Trace step 2 got the response, and it's trying to figure out what to do with it. So here's the contents of the response, and then it's going to say, it's going to have to format it in a way that makes sense. So it's saying, okay, it's got something, now it has to format it. It's done all this formatting.
Yeah.
So this is how this works. We can interact with this in the normal way. So we can say, add a comment to the visit construction sites task saying, bring your hard hat. And it should figure out, again, if we just show trace, it's going to figure out, okay, I can invoke that model. It's going to have to figure out which one to do. Oh, it can figure out in the post.
Yeah.
There it is. That's the one that it's going to do. And then it's going to decide to do that. And then so if we look at, and I think it's so cool, like all of the different decisions that are going on here.
It's
deciding
basically
to
the
actually,
chain of thought here.
Yeah.
For the LLM itself, or for the agent.
Yes, so now it's deciding, and in the context here is right. It's deciding to call the LLM. It's saying I've added the comment.
Yeah.
It's telling me about that, and then in the post-processing trace, sometimes it'll decide, oh, I'm going to refresh the list. And then if we go into ClickUp, I think we will see over here in the visit construction sites, bring your hard hat. So it actually did it.
Yeah.
So I think that's so cool.
That is
so now, if you wanted to see that, this is a pretty cumbersome way of working with it. But what we can do, if we go back to our Bedrock agent. So here's our agent.
Agents.
Okay, so the two important identifiers are the agent ID and also the alias ID.
Yeah.
Now, I found this pretty cool project over here called Bedrock Agent Test UI. It's a really simple Streamlit project. And all you do is you set those two environment variables, and your environment, of course, has to have credentials that can invoke an agent.
Right.
And so it's going to load up your AWS access key and secret key. But assuming those are right, you can then have an agent. You can have a UI that looks, familiar. And let's try this again. Let's do list ClickUp tasks. So this is Haiku powered. And note, again, this app is not doing any of the calling. The API orchestration is all happening safely on AWS behind the scenes. It's not, it's all encapsulated with AWS. This is just a simple Streamlit app. Okay, so interesting. It returned it to me as a bulleted list. Now, I was initially skeptical that this was going to work, but I wanted to say, give me the list in table form, include priority and tags.
There we go.
Okay. Add due dates. And so we're getting table form, and also because this is Haiku, it's relatively snappy.
Right.
And that's another cool thing is that when you're using ChatGPT, I love ChatGPT. Sometimes it can just get really slow. You can swear you're just watching the tokens stream in like Morse code. Yeah. Whereas this, you have provisioned resources that are at your disposal. So it's kind of cool. And we can do the same thing. We can say, give me a list of names which sound like famous architects, and update the study famous architects task with a comment.
Wow.
Those sound pretty good.
Pretty neat.
Renzo Piano sounds like a pretty good architect.
Le Corbusier. Also, he's dead, but doesn't matter.
And let's see. And of course, Zaha Hadid, a real architect. So let's see if that worked. This is Network of Real Architects. Oops, no, Study Famous Architects is the one I want.
Great. So it'll go back to ClickUp.
See here.
Tasks.
Study Famous Architects. and I should have, did it add the comment? Let's see. Add this list. Huh, it says it did it. So I'm very curious to know where that comment is. Let's try that one more time.
Just add this list too. So one of the things that I'm finding recently is that these LLMs are great at going down one direction and solving one approach. But if you're asking them to do multiple things at the same time, they generally struggle. Like this is one task. The previous one was two different sets of queries.
There it is.
There it is. Great.
So here, that's great. Here's a list of names that sound like famous architects. Great. So this is kind of cool. Like we've got the same functionality. For me, the coolest part here was in the deploy step, where we actually generate these open API specs, and then again in the CDK, they get imported here. And these open API specs, if we look closely at app.py, okay, so looking at app.py with the add comment, here we go. This is what's really useful. We're using this as input. It is taking a task add comment class. And so if we look at task add comment, it's a task ID and comment ID.
Right.
And this derives from base models. That's Pydantic. And so for me to make these, I just type into ChatGPT, I need a Pydantic model that has these fields. And then so looking at task add comment, and then here, this is important, this annotated part is actually going to get pulled into the OpenAPI spec, and you can say, okay, well, what's in there? And then here, this is a description. And again, this description also gets pulled into the OpenAI spec. And then finally, it's smart enough that it knows the return function is of type task update model.
Yeah.
And that one's a pretty simple one. It is a task ID and a Boolean.
Got it.
So if we run this add comment to task function, that all gets pulled into the OpenAPI spec, which then gets uploaded when you do CDK deploy.
Got it.
So this is the whole thing all in one, and you can start with it right now. So feel free to, this is set up as a template repository. I tried to make some really clear instructions. You need Docker installed, you need a policy, but once you have all that, you can start making agents, and then all you need is the agent ID and the alias ID, and you can use that Streamlit interface. So you can have your own ChatGPT-like interface, but powered by Haiku. And
your data, most importantly.
Your data. So the next step with this is to connect this to a knowledge base.
Yeah.
So what I was thinking about doing was using Haiku to watch a bunch of clips from Seinfeld and have it produce a relevant clip with every answer.
Got it.
And then with Streamlit, I can actually have it play that relevant clip.
Yeah.
Right? Because I can say, okay, here comes a clip as part of the response, so play it.
Yeah.
And that's where you can.
I think the challenge there is that Seinfeld episodes are 20-something minutes each, and Haiku will probably do 20 images at a time.
I can
do a video.
I can take the transcript with
timestamps. You can absolutely do this with timestamps.
And then add that to a knowledge base.
Yeah. That
have a Seinfeld knowledge base. And Bedrock agents easily integrate into knowledge bases.
Correct.
And again, you have all the data in one spot.
Excellent.
Well,
so please try this repo out. Try this out. Try out Bedrock agents and try out the Lambda Powertools. And please give us feedback on what you think about this repo. Anything that you'd like changed, anything that you're getting stuck with, we'd be more than happy to take that feedback and bring it back to you in terms of this code. Anything else we wanted to cover today, Steven?
No, it's just really cool to see how, when you first log into ChatGPT, it's kind of magic, right? And you see all the stuff happening, but then to actually build it yourself with these familiar components. Okay, here's a Lambda function, here's a policy, here's some stuff that I'm familiar with, plus some new stuff, right? You've got the agents, the action groups, you have to learn a bit of the terminology. But once you've got that, you can actually have a very similar experience that's totally within your control. I think
Completely agree.
that's really exciting.
Couldn't agree more. Once again, thank you all for joining the show today. We really hope that you found this useful, this walkthrough. And if you have any questions, please reach out to us at AWS Made Easy.
All right. Well, have a good weekend, everyone. We will see you on Tuesday. Take
Thanks,
care.
everyone.
Bye.
Bye-bye.